Okay. So hi, my name is Istvan Szmozsanszky. You guess why I go by the moniker Flocky all the time. Uh, so I'm going to talk about a lot of things, mostly and not a lot of things. So someone did this earlier. How many of you do Node? Doing Node, like really doing Node? Okay, that's all right because I don't really want to talk about Node at all. I still have to because these things are connected. You cannot go about it by not talking about Node. And I'm also not going to talk about, I'm not going to teach you how to do Rust. Have anyone heard about Rust? Okay, have anyone tried Rust? That's better. Now we are on the same page. You're so much better at Node than me. Now, at least there is something I'm better than you. All right, so about me, just short. I call myself a JavaScript developer because when you call yourself a front-end developer or something like that on Twitter, you just, all people rushing in want to do their design, their UX, their whatever. So I'm a JavaScript developer. I'm a contributor for Mozilla and a community tech speaker. I do not work for Mozilla, but I do, they do not pay me, but I do work a lot for Mozilla. And I'm a Tesla project member, a team member, which if you were here for Kelsey's talk, they do not pay me either. So life is getting tough. So I'm a front-end trainer at a company at Budapest. It's a really great place, and I get to teach, which I do a lot for Mozilla for free, and they pay me for that. So the best thing about that. Yeah, and also I'm a lot of things, and I'm in the Hungarian Rust community. We are trying to put together a European Rust community. So if you're interested, just reach out to me. We would be glad to include you on our conspirations of future events and things like that. So yeah, Tesla 2. I'm totally going to. Well, I would like you to know a bit of, if I find the right slides. Okay. Let's just, oh, there you go. Okay. So the Tesla 2 is, sorry, got mixed up a bit. So the Tesla 2 is a Node microcontroller, a Node-based microcontroller. You might have heard of it. You have heard of it definitely from Kelsey. It's a bit of a, well, we are still working on it. So a lot of things doesn't work. The things I'm going to tell you about don't really work either. And that's because Tesla, it's a new thing. It's not really out yet. And Rust is a new thing. It's just reached 1.0 this May. So all the things that got into the Tesla and that were related to Rust were in the brittle state when Rust was still pre 1.0. So you could imagine how many changes got into the API after it stabilized. But after it stabilized, Rust has stabilized, and now it's very well recommended for a your own business use case. I could tell you, but I keep refrain from telling you. A lot of big companies that use actually Rust and rewriting parts of their software in Rust. Okay, so why so rusty? You could ask. If any one of you have heard of me, follow me on Twitter, well, whatever, you might have came across this article I wrote, and it's basically about how JavaScript is going, well, basically dominating the landscape of programming languages. There are like 300 different very statistically accurate descriptions of this and images floating around on the internet, how it's now the number one language on GitHub and whatever. And I tend to preach that also, but so it's not about divide, it's about, your JavaScript is huge. But it still has places to go, and it still has its force and its still has its problems. So there are a lot of microcontrollers out there, and there's a Tesla one here somewhere. There you go. So that was the Tesla one. You can see it on the middle. It had a lot of like expansion ports and things like that. And you could program it by JavaScript, but it wasn't running JavaScript. It was running Lua, because you cannot really cram a JavaScript script engine into a small microcontroller like that. And we know that we, of course, do a lot of things. We just as Susan said, we still connect to these microcontrollers from our computers. We still connect to our nodecopters via Wi-Fi from a computer that's running this kind of stuff. We still use Fermata and this kind of fast stuff. So Tesla figured, okay, Lua's like JavaScript. We don't have a JavaScript. It's like the V8 compiler. It's like the runtime engine. With all things stripped, is like 2 or 3 megabytes at least when you compile it. So it doesn't really fit like a microcontroller. The original Tesla had like 200K of memory. And you can expand on that, but if you try running code on that, that's going to hurt you. And there are a lot of other stuff. So they just figured, okay, this is Lua. Lua is a great script engine. It's embeddable and things like that. So let's just go with that. And they went with that, and they figured we could just write a transpiler. Have you ever heard of Babel? Transpilers are all the rage these days. So they figured they just write a transpiler, compile your JavaScript code into Lua. And if they work hard enough, they might even accomplish node compatibility. There is a second microcontroller on the top left. It's the Node MCU. They doesn't even try to hide this. So yes and no, because it's Lua. I'm getting behind on my slides. I'm sorry about that. They didn't even try to hide it. Node MCU runs Lua out of the box right on the microcontroller. And they have node-compatible or node-like APIs for file system and things like that. So you feel quite at home, but it's still not Node.js. And Samsung, you may have heard of JavaScript. Yay! Yeah, so there was a few engines out there, like duct tape, that was like small things that you could fit onto a bigger microcontroller. And Samsung, back in the days, did a really great evaluation of all this stuff. And they decided to roll their own JavaScript engine that could run on the microcontrollers. And they decided to make it, node compatible. And what Tesla couldn't do, well, this was just a small bunch of people, and this was an uphill battle trying to keep up with all the changes going into Node. They figured Samsung, maybe their resources could be able to do it. What Tesla decided with the Tesla 2 was to go from the opposite and just have a Node controller, a Node-based controller that actually runs IO.js or Node.js. Or we are at IO 2.0 right now, but I think it's going to be an easy transition into Node 4.0 when you all tested it. So they went with a new engine and a new approach. So this is like a Linux-based microcontroller, and you could ask, why would you use a Linux-based microcontroller if it wasn't like a Raspberry Pi or something? Well, because they went with a Linux-based microcontroller that had a kind of an I/O chip inside it. So they are trying to get best of both worlds. You could say that, and because it's Linux-based, you're not limited to any language. You could like do C if you wanted to. You might not want though, but we are getting to that. So then why Rust? So Rust, it's just a programming language. It's a new programming language, that's all right. But, don't do this. Rust is not the doom, not going to slay down all these lowly languages like C and C++. It's not out for that. It's not out for blood. Yeah, it's just going to, result in whatever, more flame. So programming language is a tool. And yes, that's Mark Surman, Executive Director of Mozilla Foundation, at one of the Mozilla events with a chainsaw. So yeah, it gets fun sometimes there. So programming language is a tool. And you can only use a tool if you know it. If you never heard of a tool, you never could use it. But sometimes you're better off with a tool that you know well. If you're like an artisanal woodcutter, you better stick to the axe if you've never seen like a chainsaw before, because you're not going to cut trees but limbs off. So just stick to the tools, if you're going for production. But if you're hacking, and that's what Dessel is for, just putting together stuff that's like works great, and prototype stuff like out of the box. That's what the whole Dessel thing is all about. Then you should just try things out. You should break things. You should break things, and yeah, don't try to break a Tessel. They are cheaper. The new ones are cheaper, but not that cheap. And there are not very much of them, so they are precious. So what's Rust then? Rust is a new programming language. I think I have like -3 minutes, and I still haven't talked to you about how to use Rust with Node. Okay, so Rust is a new programming language. That's the low-level programming language that you could use instead of C or C++. And it actually helps you. It helps you a lot of ways. There are a lot of pages out there, web pages that you could learn how to do Rust, and it's actually not all that scary. I might show you. So here is Rust code somewhere. There you go. There you go. That's the FizzBuzz. Who have never heard of FizzBuzz yet? Okay. Yeah, I was vaguely familiar with it, but I never really knew this was like a hello world or something. So FizzBuzz implemented in Rust. They have pattern matching. You might be familiar with pattern matching from other languages. So Rust pulls together a lot of stuff from other languages. And it has a compiler, so it's a compiled language. It compiles to machine code. Actually, it's compiled to LLVM. And then it's compiled to a lot of different machine code instances. And so it's completely cross-platform. But when it compiles, it has actually, people are joking, it has a complainer. Because the compiler, so the language itself has a very interesting feature called that it's based on ownership. You can only modify, you can only do stuff with properties in your code which you own, and this can be statically checked. This way, you avoid the use of a garbage collector, and you're better off when you're doing low-level hardware stuff. So when's Rust the right tool? So I told you that you could choose a tool if you know it, and there was this article. It's like, I bet you can go through it like in an hour. There is actually rustbyexample.com. It's a very great site. You get to learn the language, all the features through working on examples, and also there is it. So it has, if you've worked with Babel, it has an online playpen that you could use. Let's hope it works on the main channel 1.0. There you go, FizzBuzzing away. And this is like an online version of the Rust compiler. You could try most of the things out without even installing Rust. So you just learn that, okay, what to do with it. And you shouldn't do it unless you want something out of it, yeah, right? So what could you want out of it? You could want speed, because JavaScript is great, V8 is great. It's like leaps and bounds behind anything JavaScript has ever been, and it pulled with himself all the other languages, all the other JavaScript engines, Chakra and SpiderMonkey. They are all through the roof. And there are a lot of things that JavaScript's good at, but on small-sized platforms, you're going to need speed and you're going to need the predictability of a code that doesn't use a garbage collector. And also, you might need you might want to be power conscious on a small microcontroller, because on a small microcontroller, you only have like if you want to like power it from a battery. The code you don't run, the shorter amount you utilize the CPU, the best it turns out. So there are two ways, fundamentally, to work with Rust from inside the Tessel and basically from Node.js. Have you heard of the Node.ffi? All right, not much of you. So Node.ffi is actually a C binding for code. So you code your stuff, you code your library in C, and it exposes C bindings for the code. And you just compile those C bindings could work with any other language like Node can. Node.ffi has these bindings. There is a good article. I'm going to share the slides later for your growth. And oh, I haven't started. Okay, I cannot click it actually because I'm still in editing mode. Sorry. So might work. Oh, there you go. Yeah. So there's this article. You could check it out, and it would guide you through the steps. It's quite basic. Yeah. Then we go to actually diving into hacking. So let me hook up. There was a shout out for Amazon Prime before. I might need that service too because my little webcam that's supposed to be showing you this one is somewhere on the border between the UK and Budapest. So sorry about that. So you will just have to believe me. Maybe I can fire up the webcam. That might work. Oh, there you go. Hi. Okay. Let's just put this away. Oh, no. And so I'm going to show you. So you could do, with a Linux-based controller, is you could run Rust, compile Rust on the controller itself. But, this is like an ARM chip. You have to compile stuff and things like that. So there is this repo in there. I'm not finding my way on. Tessel Rust, there you go. So it's a bit contrived. You have to fire up Vagrant and get the OpenWRT SDK, whatever. And you have to cross-compile and copy stuff onto your Tessel. This is going to change by November, hopefully. So, but if you want to help out, it would be a nice way to. So once you learned Rust, you need a project to do it on. So you need something to get you into that. There you go. We are online, hopefully. Let's see if the Wi-Fi works. There we go. Okay. We need a special Wi-Fi for this one. No, it doesn't seem to work. Shit. I mean, apologize. All right. Okay. Yeah, the problem seems to persist. So, all right, yeah, you just have to believe me then that it works. Yeah, there is a tweet I tweeted yesterday. So that's a proof of concept that it works. No, okay, let me just show you the code then. Should be here. All right. So what you do on the Tessel, you have to interact with the small microprocessor that's next to the chip. Let's see if I can get this up to you. Oh, there we go. So there is a Rust code that does the heavy lifting. So what you want to do is, okay, I have a computation that takes a lot of resources. I don't want to, have the V8 engine crunch through all that data because it would just deplete my battery in my device. And so I just create a Rust binary and just call it like any other binary on the device. You could even, set up a daemon via a local socket or something. So what's interesting about these kind of stuff is that you can not only access. So what you this one you could do on any device. You could do on a Raspberry Pi. But Rust provides you Tessel on the Rust on the Tessel provides you APIs that make it easier to, this is just using an accelerometer. I might be able to use this thing for something. So the setup is, that's the Tessel. That's just the display I hacked together. This is just $10. You order it from the internet, connect it via UART, something like that. That could be any. Oh, I just unplug it. Oh, there you go. So that could be any other device, but that's actually an accelerometer. So when you do an accelerometer, what it does is Rust and the library actually abstracts away all this stuff and gets you back nice and precious data. You could actually connect to because the new Tesla 2 has a USB. You could like connect to your camera and things like that, and just do it like that. And you crunch through all the data, lower to the level, lower to the hardware. And you just make it until you break it. Well, hopefully you don't break it. So you have a Rust application here that creates a new listener, a new server, sets up a new server, and it actually spawns on a new socket. You can see here. You can see that the code is not all that bad. In Rust, you don't have to, manually memory manage, collect your strings together from character data and things like that. It has UTF support, so it's actually not that bad. And when you run that, you actually run besides it a Node.js instance that you can see here. And the Node.js instance just connects to the same socket. First of all, of course, it spawns your process. It spawns your binary, it connects to it, and just gets all the data crunched by your Rust instance. You could do the Node.ffi method, but the Node.ffi method has several problems because you're translating like JavaScript objects to and from native objects. It has quite a big issue with performance and overhead when your calls are happening. And you avoid that by using actually crunching and pushing through binary data through the sockets. So if you want to help out, there is this repository. It's actually not Flocky, but Tessel. Yeah. But anyway, so it's github.com/Tessel, and there is Tessel project, Tessel Rust, and we need a lot of help. If you have some empty weekends, just dive in. And the nice thing about Rust and Tessel is that they are both actually open source technologies, so you can even contribute to Rust himself. They are doing 1.2 these days, and it's going through the roof, contributors lines and things like that. So I think I'm finished. There you go. If there are these slides are on the link above, and just hit me up with questions if you have anything. I'm really around. Thank you.